Hey, it's Mr. Dean. This time we're talking about right triangle trig. A little different than unit circle trig, but similar. In unit circle trig, the radius was always equal to 1. If you drew a triangle in the unit circle, the triangle's hypotenuse was always equal to 1. But in right triangle trig, the hypotenuse can now be any size we want. It can be smaller than 1 or larger than 1. And right triangle trig and everything that we learned through this video and right triangle trig world is only good for angles that are between 0 and 90 degrees, so not good for obtuse angles. We'll study those later. But you got your three definitions here for sine, cosine, and tangent. Sine is equal to the opposite side over the hypotenuse, and that's all from the viewpoint of the angle that you're referring to. So if you're referring to angle A down here, then we're looking over at opposite being across from that. The hypotenuse is always across from the 90 degrees angle. Cosine of an angle is always equal to the adjacent side. The adjacent side will be the leg that's, of course, touching or adjacent to the angle. Hypotenuse remains across from the 90 degrees. And the tangent of the angle is always the opposite side divided by the adjacent side. So sine, cosine, and tangent are ratios, okay? Some people like to think of it as, for example, sine is the percentage of the hypotenuse that the opposite side is. Some people like to think of the cosine as the percentage of the hypotenuse that the adjacent length is. All right? And tangent, again, can be thought of probably in simplest terms as the slope. So a mnemonic down the bottom for remembering these three ratios is SOHCAHTOA. Just have to be able to really pronounce it correctly, so that you really emphasize in the O part. So it's so with an H. That just simply means that sine is opposite over hypotenuse. Ka is adjacent over hypotenuse. And tangent is opposite over adjacent. Be sure not to think of it as SOHCAHTOA with a H sound at the end. You really want to make sure that it's opposite over adjacent if you're going to use that SOHCAHTOA abbreviation. So let's get right to it. Here's an example right triangle. Again, this is all for right triangles with 90 degrees in them. And you have an 8, 15, and 17 lengths, and you want to find the 6 trig functions of the angle. So the angle that we're referring to, of course, is down here. We're not going to find what that angle is, what that measurement is. So we're not talking radians or degrees. The answer to all 6 of these questions is going to be a ratio. All right? Really important to remember. So sine is part of the SOHCAHTOA. Sine is opposite over hypotenuse. So from the viewpoint of this angle, opposite over hypotenuse. So you're going to have 8 over 17. All right, the cosine, start again here. Cosine, that is going to be the adjacent over the hypotenuse, and that's 15/17. And the hypotenuse, the tangent's going to be the ratio of the opposite over the adjacent. So it'll be 8/15. Now, the reciprocal functions are just as easy. There's not really a mnemonic for it, but you just remember that cosecant is the reciprocal of sine, so it should be 17/8. Cosine and secant are reciprocals, and cotangent and tangent are reciprocals. No need to memorize a new mnemonic. Just remember that they are always reciprocals of the ones across from each other. And if you're writing your six trig functions down like this, you often see them like sine, cosine, tangent on the left, and then across from them, they're reciprocals. You get into that pattern and you can't forget it. Now this is sort of a real close blow-up of the unit circle again. And we're not leaving the unit circle idea. It's still something that we can use. But now if we think about as triangles in the unit circle, all right, and these are radians going around, not in terms of pi, but in terms of tenths, 1, 2, 3, 4, 5, 6. This is about 0.62 radians. And that angle has for example, a sine of that angle. So the sine of, I guess in this case, 0.62 is equal to the y coordinate or now in terms of SOHCAHTOA, it's equal to the opposite over the hypotenuse. In the unit circle, the hypotenuse is 1. And looks to me like, if I go over, looks to me like the y side, or the opposite length, is going to be roughly 0.59. So using SOHCAHTOA, sine is equal to the opposite over the hypotenuse. So the sine of 0.62 radians is about 0.59. And using the percentage idea, with this angle, the y side is about 59% of the hypotenuse. Now we'll use another example here in red. Again, SOHCAHTOA, very helpful. Let's get busy here. Sine of the angle opposite over the hypotenuse. But the hypotenuse is not here. All right, so we have to do a little Pythagorean work. A squared plus b squared equals c squared. So on this side you have, let's say, 36 plus 64. And it looks like c squared is going to be 100, making the hypotenuse 10. So we use that information. The sine is equal to the opposite over the hypotenuse. We'll simplify 8/10, 4/5. Cosine, that is equal to the adjacent over the hypotenuse. We'll simplify that as 3/5. And tangent is equal to, use another color here, opposite over adjacent. And notice tangent's the only value allowed to be more than 1. Its reciprocals, put that back, its reciprocals are 5/4, 5/3, and 3/4. I'm just taking the reciprocals of these values over here. So those values are reciprocals. It's helpful to remember your Pythagorean triples because you see these numbers appear a lot in 90-degree triangles. So 3, 4, 5, 6, 8, 10, 9, 12, 15, all multiples of the 3, 4, 5s. And then you also have 5, 12, 13ths, and it's double, 10, 24, 26. So these are just, Pythagorean triples are just legs of triangles that happen to coincide with nice whole numbers, nice integers, rather than decimals or square roots. All right, now, special triangles, super important. The most important thing of the week, of all time, of your life, is to remember these two special triangles. There really aren't 3, there's just 2. The 30, 60, 90 one sometimes is thought of as 2 separate triangles, but I like to keep it simple. All right, and let's get busy here. Sine of 30 degrees. The way to do it is just remember your SOHCAHTOA. Keep writing that down. And the sine of 30 degrees is 1/2 over 1. Because we're going to use that 30, 60, 90 special triangle. You got to have this memorized. I like to think of, it's just a memorization trick, is that the 1/2 is always across from the 30. And it just so happens that 30 is half of 60. All right? The 30, 60, 90 triangle is the triangle with 3 separate angles. And so I remember the 3, root 3 is on top. And if you look at all the fractions on both for special triangles, all the legs have a fraction, a denominator of 2. So there's not as bad to remember it when you kind of remember these patterns. All right, let me get rid of all this stuff we added in, and let's get to the next question, cosine of 45 degrees. So I got to go over to the 45-degree triangle. I just simply choose either angle, and I just need to remember that cosine is adjacent over hypotenuse. All right, and you can see in these special triangles, I've set the hypotenuse equal to 1. This is going to make your life a lot easier with trig. If you're constantly needing to divide by the hypotenuse, well, then if the hypotenuse is 1, there's not much to it. All right, next example is tangent of 60 degrees. Now we look over from the viewpoint of this 60 degrees, and remember that tangent is opposite over adjacent. All right, root 3 over 2 divided by 1/2 is the same as root 3 over 2 times 2. and we get root 3. All right, now let's try, get this off the page here, cosecant, there it is, cosecant of 30 degrees, some reciprocal trig. All right, find your way over to 30 degrees, and cosecant is the reciprocal of sine. So we'll say it's 1 over the sine of 30 degrees. Find the sine of 30 degrees and flip it. So the sine of 30 degrees is opposite over hypotenuse. It's 1/2 over 1, which is 1/2. And then when we flip that 1/2, we get 2 over 1, or 2. The secant of 45 degrees is, and I'll just kind of write this, you can also write it like this, 45 degrees and the reciprocal of that. So first we find the cosine of 45 degrees. Come over here, take the adjacent, divide it by the hypotenuse, but then we have to flip that over. So 2 over root 2, we have to rationalize the denominator. It turns out, even though it doesn't look like it could possibly be true, 2 over root 2, yeah, is equal to root 2. Next example, cotangent of 30. So, get all the stuff out of the way. Cotangent is the reciprocal of tangent. So you just go over to the 30 degrees, and you're thinking, opposite over adjacent. All right, that's a little bit of work. But actually, if we're going to find cotangent, sorry, we're going to flip that around. Adjacent over opposite. So tangent's opposite over adjacent, we'll just flip it over to start. So we have root 3 over 2 divided by 1/2. And that's going to make our life a little easier. All right. Dividing by 1/2 is the same as multiplying by 2. And when we multiply by 2, you can see we get root 3. All right. Now, this is kind of a memorization device to sort of clue you in, or I don't know, I guess you memorize this and then you know all your trig values for sine and cosine for the first quadrant, 0 through 90 degrees. I'm not a big fan of this, but you can look at this and kind of figure out how it works. So the cosine of 45 degrees, if you've memorized all these numbers in this order, is root 2 over 2. They're all divided by 2. So that's how that works. If you want to, cosine of 0 degrees is root 4 over 2. But of course, root 4 over 2 is 2 over 2, which is 1. So the cosine of 0 degrees is 1. But I kind of think if you can memorize all that, you can kind of just memorize your special triangles and know how to use them instead. There's also a hand memorization thing. It's kind of neat. It's not bad, but I would never use it. If you want to figure it out, there's lots of videos online. Go to YouTube and just type in trig hand trick, and you'll find out all about it. All right. Those two special triangles. That's all you have to memorize in order to memorize, really, in order to be able to get the entire unit circle, all the values for all the angles, all the special angles at least, all around, and all the quadrants. So memorize those two special triangles. It is crucial. Immediately memorize all those special triangles. That's an order. This is Mr. Dean, and I'm out of here.